Hi and welcome to the third video on ISIS with our lab workbook number 3. Okay, so you'll notice from the last two workbooks that our topology has changed slightly. So we've added in PEs 10, CE11, PE12 and PE13, and in this video we will be concentrating on IPv6, plus we'll go through another few little bits and pieces. Okay, so our instructions here is IPv6 addressing, and ISIS IPv6 has been completed on areas 1, 2 and 3. So these were our original areas we used in the last two videos. So task 1, so area 4 will need their ISIS IPv4 adjacencies using the NET format like we did before as 49 dot the area dot xxx dot the router number and the end cell, whereas area 5 and area 6 will need a very similar format, but it will use another set of 4 or another octet in there. Okay, so what we want to do then is that once we've got the IPv4 adjacencies set up, we want to have a look at the ISIS database on CE11 and CE4 and see why they're different. And this may tie into something that you may have noticed in the last videos regarding ISIS. Okay, and then once we've done that, we will add our IPv6 addressing to the routers in areas 4, 5 and 6. Okay, so, and once we've done that, we'll go through some of the questions as well. Okay, so let's jump onto the command line and let's jump onto PE10. So there's PE10 at the bottom, the iOS XE router in area 4. Okay, so PE10, sweet, here we go. All right, so let's go into enable mode and let's quickly do show ISIS protocol. Okay, we can see that ISIS is not running, so that's fantastic. Okay, so what we'll do, let's go into configuration mode and let's go router ISIS, and on the actual instructions as well, I should have mentioned that it said here that I'm sure I put that on here. Sorry, give me 2 seconds. Examine IP addressing. Okay, so what I should have put down is that we wanted to, instead of using process ID 1 like we've normally been doing along with the last two workbooks, is that we're going to rename it slightly differently. So let's get cracking. So we've got router ISIS and I'm going to call it area 4. All right, and let's do our net address. So net address is going to be 49.000.000.000.10 because it's router 10.0.0. So that's our net address, and let's do our passive interface. So our passive interface is going to be loopback 0. All right, that's fantastic. So what we need to do now is configure, well, that's what we configured just now. We'll do the IPv6 addressing afterwards. So let's go on to interface G1 and let's do, so G1 is going back towards CE1, so let's do IP router ISIS area 4, and this will be, as we see through the topology, G1, so P10 to CE11, this is going to be level 1 adjacency. So let's do ISIS circuit type level 1, and let's now go on to G3, which is our link to PE23. So interface G3, and let's do our, sorry, my brain's just stopped it. Yeah, so let's do IP router ISIS area 4, and this is going to be a level 2. So we're going to do ISIS circuit type level 2. Okay, that should be it. I can't remember whether I took the IPv6 addressing off here. So show IPv6 interface brief. Okay, excellent. I have taken it off, so we can put that back on in a moment. Let's do a show ISIS neighbor. Okay, so we have no ISIS neighbors at the moment. That's absolutely fine. Just what we expect. Let's jump on to CE11 now and do the neighborship between PE10 and CE11. Okay, so let's go enable conf t and let's do router ISIS area 4, and let's do our net address as 49.0004.000.000, oops, 11.00. Okay, so that's fantastic. And let's do our passive interface as loopback 0, and let's do the link going between PE10 and CE11, which is gig 1. So I exit interface gig 1. Excellent. And let's do our ISIS on that. So IP router ISIS area 4, and ISIS circuit type is going to be level 1 only. It's a level 1 adjacency between them. Show IP interface brief. Let's see where we're up to on that. Okay, so let's see, make sure we can ping PE10. So do ping 10.2.11.10. Okay, so we have connectivity between them. Okay, let's do a show run section ISIS. Okay, so we have our area type, we have our passive interface, and we've set the circuit type on this device as well. So do a show run interface G1. Yeah, so we have our IP router ISIS area 4. Okay, do we have a neighborship? Show ISIS neighbor. We have no neighborship with that. Let's quickly check PE10, see what's happening. Show IP interface brief. Okay, and we know we can ping, so let's check our configuration. So show run section ISIS. Oh, okay. So guess who left the net statement out? Okay, so router router ISIS area 4. Let's do the net statement. So net statement is 49.000.000.000.10.00. Okay, that should resolve that particular problem. So we have our adjacencies come up now. So show ISIS neighbor. Okay, so we have our neighborships. Show IP route ISIS, and we have our routes up here. Can we ping CE1's loopback? So ping 1.1.1.1. See if this goes through. I have to source it from my loopback. Actually, do we have that in the routing table? To be fair, I didn't even check. No, we haven't got that in the routing table. Okay. Ping 2.2.2.2. There we go. All right, great stuff. All right, you can see this is exceptionally well scripted. I don't use scripts at all. Okay, so we've done PE10 and CE11. So we need to do PE's 12 and PE's 13 as well. So let's go on to PE12. Now PE12 slightly different. We see we have two connections go into PE1 and PE22, both to XR routers. So let's get cracking with this. So let's go to enable conf t, and let's get our router ISIS area 5. Okay, net for our net statement. Now if you remember from the instructions here. Let's get the instructions back up. The area 5 and area 6 are using the longer address format. Okay, so we have our net, and it's 49.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0.0. 0. Brilliant. Okay, so now we need to configure Giga Ethernet 2 and 3 because they're the ones linking back to the respective iOS XR routers. So let's go into interface, and it's going to be Giga Ethernet 2, and let's do IP router, and it's going to be ISIS area 5. We don't really need to put the circuit type in because it's going from one area to another area, so it'll automatically do a level 1 neighbor, sorry, level 2 neighborship only. So if we was to do show ISIS neighbor, we can see we only have a level 2 neighborship. If this was within the same area, then of course it would try to attempt to do a level 1 and level 2. So we don't have to put the actual circuit type in on this. So that's actually fine. And let's jump on to Giga Ethernet 3 INT. So it's going to be Gig 3, and we're just going to do IP router ISIS area 5. So the reason we're using names instead of numbers is because a lot of videos we've gone through in the past, and some of the other ones I've created for other projects, just using numbers generally, you know, ISIS process ID 1, 4, 12, 89, etc. Just to show you that you can actually do it in a named format if you want to as well. And let's do a show IP root ISIS. Okay, we have neighborships, do we not? Show ISIS neighbor. Okay, so we have neighborships. Show IP root. Okay, okay, we got no neighborships come up here. No roots, rather. This is interesting. Let's investigate why we've got no roots. So let's jump on to PE23. That should be the next one up. Oh, sorry, PE22. And let's see how that's actually configured. So let's jump in here and go, and let's do a show run begin ISIS and see what we have here. As we already know from the instructions, IPv6, IPv4 adjacencies already set. Okay, so this is most likely our problem, is that we are using single topology. So single topology basically means that it's going to run the same database for both IPv6 and IPv4, which, you know, within your core, etc., you know, that's generally fine. Problem being is that when you're using single topology, the ISIS protocol expects everything to be using single topology, i.e. if you're running IPv6 on this, then it expects the neighbors to also be running IPv6. So let's see what happens when we change this to multi-topology and see whether we actually get the roots then on PE12. So let's go into conf t and let's do router ISIS process ID 1, and let's go into our address family IPv6 unicast, and let's go no single topology, no SI, and let's commit that, and we'll see whether or not we get our roots coming in. All right, let's jump on to PE12 and have a look, see if we get any. We notice that adjacency has changed slightly, and let's do a show IP root. Show IP root. There we go. Now we can see that we're getting the ISIS roots being learned. I said there is a few gotchas when you're using IPv6, you know, and again with the single topology versus the multi-topology, this is a bit of an issue. So what we can do, instead of maybe breaking our core, we will add the single topology onto PE12 to make sure that that's using, sorry, we will leave it as it is for now, but once we do our IPv6, we'll change it back so it's using single topology on our core devices rather than splitting the databases. But as it stands at the moment, we have to split the databases from single to multi from single to multi topology on the PE to get the actual routes to come through, only because again we're not running IPv6 and ISIS expects on single topology both processes to be run if one of them's running it. So like I said, bit of a gotcha, but we'll work through this. So we've got our route, which is fine. So what I'll do, I'll jump onto PE1 as well, and I'll change that from single topology to multi-topology. Okay, that's been changed. Let's have a look now on PE12. Okay, adjacencies now come back up. So we should have all the actual routes. So we've done now PE12. Let's jump on to PE13, which is the iOS XR device at the top. And let's get that one cracking. So, all right, great stuff. So router, ISIS, area 6. And let's do our net address on this one. So our net address is going to be 49. Yeah, it should be 49.000.000.000.000.0013.00. Okay. Now we need to globally add in the IPv4 and IPv4 address family. So address family IPv4 unicast, and let's go into interface loopback 0. We'll make it passive, and we'll add the address family IPv4 unicast, and our interfaces, if I remember rightly, Gig Ethernet 2 and Gig Ethernet 3. So let's do INTG 0/0/0/2 and address family IPv4 unicast, and get out of that and jump up to 3 and address family IPv4 unicast, and let's commit that. All right, do we have any neighborships on here? Show ISIS neighbor. Yes, we have. We've got 2 level 2 neighborships. Again, because it's different area, we didn't even have to stipulate that it was level 2. And let's do a show route. Now, this is strange. So you noticed how we didn't have to change the topology type from single to multi-topology. It's because by default, the iOS XR devices come up as multi-topology. So we didn't have to change this. iOS XE defaults to single topology. Okay, so that's really good. All right, so we've now completed our first task. All we need to do now is have a look at our databases on our CE4 and our CE11 and see what the differences are on this. So let's go on to CE4 and let's do enable, show ISIS database, and let's go detail. Okay, so we notice that this is obviously a level 1 router. We know this, before we use this prior, but this is what is interesting. Firstly, we are routing for area 49.0002, and we have the attached bit, because you'll notice from the previous video we didn't have the attached bit. We played around with some redistribution and propagation. Now we didn't have to do that here, because you'll notice here that the area address is correct. But if we jump onto CE11, remember we put the net address in differently. So enable, and let's jump into show ISIS database detail. Now you'll notice here that the area address is only 49. So if you use a 6-bit address, then it will automatically default to using 49 as the area. So when we was configuring ISIS in the previous videos and we done the address format the same as we did here, the reason why the attached bit wasn't being sent is because as far as all the devices were concerned, they were all in area 49. So to get the attached bit to actually be sent, the stipulation must be that there must be a level 2 connection to another area and a level 1 connection to another device in the same area. If those stipulations are met, then the attached bit will automatically be sent, and the attached bit will send the default static route. So show IP route, and here we go. You can see we have the default static route here, which is exactly what we expect to see. Now, if we had used the same address format for all these devices, then none of these end devices will get the default static route at all. We would then have to use propagation and distribution to actually get the level 2 routes into level 1. Okay, so that's fantastic. This video's going a little bit longer than I thought it was going to be. Okay, so we now know the difference between using the slightly different format of the addressing. ISIS, unless there's the correct amount of bits in there, it will ignore the rest of the area and put them all into like area 49, which is not good. Okay, so let's do a ping. Let's do a, actually we can't do a ping because it's not set up ISIS. Was that that wasn't a stipulation? Oh right, add IP address routing. Okay, yeah, that makes sense. How to do a ping, you know, if you actually have the IPv6 address routing put in. All right, let's quickly jump on and get that done. So let's jump on to PE10, enable conf t. All right, and let's go interface loopback 0. All right, and let's do our IPv6 address, and it's going to be 2222 db8 colon 100 colon 10/128. All right, and let's go on to interface, and let's do G1, so this is going back to CE1, and let's do our IPv6 address, and it's going to be 2002 db8, and it's going to colon 10/11 colon /64, so 64-bit on that, and interface G3 I believe, and let's do our IPv6 address 2002 colon db8, and then we're going to do colon 2310 colon 10/64. Okay, and that ping looks to have worked absolutely fine, which is exactly what we expected to see. So that's good. So let's do a show IPv6 route, and we can see we have a couple of routes in there, ones that we've learned ourselves, and that's fantastic. Okay, so let's jump on to, did we do CE11? No, we've not. Let's do a show IPv6 interface brief. Right, let's quickly configure this device then, and so let's go into conf mode, and let's go interface loopback 0, and let's do IPv6 address, and it's going to be 2222 db8 100 colon 11/128. Let's go interface gig 1, and let's do our IPv6 address. It's going to be 2002 colon db8 db8 colon 11/64. Let's end that. Let's do a show IPv6 neighbor. Do we have any neighborships yet? No, it takes a little while for it to find them. Let's jump back onto P10. Do we have show IPv6 neighbor? Yeah, so we can see neighborships there. Oh, by the way, if you want to ping the link local address, which you can do, you can't just do it like we did before with a normal ping. So if I do ping and then put the link local address in of, you know, my directly connected neighbor, you have to put the output interface, and you can't just say it's G1, or do you have to actually spell it out. So if I do GI3, I can't find that, even though it shows us that the interface is GI3. You need to actually type gigabit Ethernet 3. There you go. Or if you want to, you'll see that on iOS XE, it gives you an actual, the command that it's using, which is the percentage sign. So you can actually just do this if you want. So you can go ping and then put that whole command line in, and that works fine. iOS XR, no, you have to put in the actual physical interface on that. Okay, so anyway, back to where we was. So C11, all right, so we've done loopback give 1, so C11, so P12. And let's go conf T, enable first, conf T, interface loopback 0. And let's, we're on P12. Okay, so let's do IPv6 address 2222. db8 100 colon 12/128, and we should be doing Giga Ethernet 2 and 3, INTG2 IPv6 address, and it's going to be db8 colon, and that's going to router 12. So let's do 1212 colon 12/64, and let's go into interface gig 3 IPv6 address, and it's going to be db8 colon, actually should that have been 1212? Yeah, 12, that was 12, so this would be 22 to 12. And it's going to be colon 12/64. All right, and lastly, let's jump into PE13, and again, it's on PE13. Its interface is loopback 2 and then 3. So interface loopback 0. And let's do our IPv6 address. Let's go 2222 100 222 db8 100 colon 13/128, and int gig 0/0/0/2, and IPv6 address is going to be 2002 db8, and it's going to router 22, so it'd be 2213 colon 13/64, and let's go on to interface G 0/0/3, and let's do our IPv6 address, and it's going to be 2002 db8, and this is going to 12, yeah, 12. Okay, so So it'd be 12.13 colon 13/64, and let's commit that. Okay, so that's our IPv6 addressing done on that. So the next task was to our task 2, enable ISIS for IPv6, ensure they're propagated, and examine the routing from PEs 12 to PEs 13. Okay, so in that case, let's get cracking with where we're currently on. So we're on PE 13 at the moment. All right, so quite easy to set up on iOS XR. So let's go into router ISIS area 6. We add in the address family IPv6 unicast globally, and now we need to add in IPv6 address for each of the interfaces that are participating in this. So we've got interface loopback 0, address family IPv6 unicast, and we got interface G 0/0/0/2, address family IPv6 unicast, and we've also got here interface G 0/0/0/3, address family IPv6 unicast. Okay, fantabulous. And if you remember, we changed the actual topology from single topology to multi-topology on the other 2 routers. So we'll change that on here to make sure it's single topology, so we get everything in the same database. And we will do that on the actual address family itself. So address family IPv6 unicast, and we'll make that a single topology. Commit, and let's do a show run, and let's do a begin ISIS. All right, so we have our address family IPv6 unicast. We've set the single topology, and we've put the interfaces in as we expect. Okay, great. So let's jump on to PE12, and we don't even know what interface I'm in. I'm in interface G3. Okay, well, it's quite easy for iOS XR. iOS XE. All you do with this is on the iOS XE devices, you just put in here IPv6 router ISIS. This is area 5, isn't it, for P12? Yeah. And that's it. That's all you need to do. So you just go into each of the interfaces and you enable IPv6 router IS and whatever process ID you've got, and that is all you need to do. Okay, so what I'll do, I know the video's traipsing on, I will jump on to the other devices quickly, and I will add in that command into all of them to get that up and running. Okay, so I've enabled the address family IPv6 and the IPv6 router ISIS on all the interfaces that need it, so everything's fine. And I've jumped back onto the 2 iOS XR routers, which was P1, P22, and added them back into single topology. If you remember, we only changed them so we could actually get an actual IPv4 neighborship running. But now that we have IPv6 on our devices, then we don't need that anymore, so I've moved that back. So let's have a little look and see if we have anything on here. So let's do show IPv6 route ISIS, and as we can see, we're getting all of our ISIS routes here, which is exactly what we expected to see. And let's do a show IP root ISIS, which is great. You'll notice as well, or that we should see, that we have for our PE13 we should be getting equal cost load balancing on that. Do we have the, let's go on to PE13. Okay, let's do a show IP interface brief. No, not show IP. Show IP root ISIS. Okay, so yeah, going to router 12 here, we have equal cost load balancing on that, which is exactly what we expect to see. That's great stuff. Okay, so in the next workbook, what we'll do, we'll jump through and we will do some redistribution. So what we're planning on doing is having the likes of OSPF, BGP, EIGRP, and do some redistribution into the actual ISIS protocol. And because we now have equal cost load balancing between PEs 13 and PEs 12, what we could do, we can play around with the metrics as well, and so we can determine which path we want the traffic to actually take. And this would be a good opportunity to go through the difference between single topology and multi-topology as well, because it plays a very big role in routing decisions and what paths are taken. So I apologize, I know this video was a bit longer than they expected, but I look forward to seeing you in the next one.